All right, everybody, we are live, we are recording. So for people who are not here in person, what I'm going to be doing today is doing chapter 4 in one lesson where I break this down into four major concepts in chapter 4 that are important that you need to know. The first of which is algebraic terms. What is a term? A term is when you have an algebraic expression. I'll hide this for a second. Here I have an algebraic expression. Let me get rid of these braces here. So here I have an algebraic expression, 3x minus 2y plus 5. Now this is an algebraic expression because it has variables. Terms are the things that are separated by plus or minus signs, okay? And here we have an expression that has 1, 2, 3 terms. And we took one of these terms because we want to break this term down into its parts, okay? Now this is important mainly because I'm going to be using language, vocabulary that I want to be consistent with, and you have to know what it is when I say the word. So the number that's in front of your term is called the coefficient. It's the number in front of the term. This is the number that's being multiplied by the other thing in your term, which is the variable part. And I'm going to say variable part because sometimes this can be one variable and sometimes it can be this whole string of letters that are being multiplied together, and it can have exponents. It can be things like this. It could be, negative 5x to the third y squared z. This whole thing is the variable part. Okay, now it's important to note a couple of things. The coefficient includes the sign that is in front of your term. Okay, so if I were to, now that we know that, now that we're familiar with that vocabulary, could we go back to the original expression, this one, and could you tell me what the three terms are? Yes, Sophia?
3x, negative 2y, and plus 5.
And 5, yeah. And you could say plus 5 or just 5. If you don't say like plus in front of it, we assume it's positive. Okay. Now, if a term doesn't have a variable part, like this 5, this is called the constant term. And we learned that last week when we found out that, when I substitute numbers in for variables, the constant doesn't change. It remains constant. That's why we call it a constant. Okay? Makes sense so far?
Yep.
Okay, so we have terms are separated by plus or minus signs. They will include a coefficient and a variable part. The coefficient includes the sign in front.
Did we just learn 4.1?
That's basically 4.1, yes.
Yeah.
That's everything important from 4.1.
The first, opening class.
Oh, cool, that's cool.
Combining like terms. If you have an algebraic expression, or if you're solving an algebraic equation and you get to a point where you're adding or subtracting terms that have the same variable part, you can add or subtract their coefficients. Now that's a big long sentence. I'm going to show you what that looks like. So for example, say I'm solving an equation and somewhere in the equation I have this, 5x minus 3x. Well, because these two terms, the 5x and the minus 3x, have the same variable part. Now, the same variable part means that you have the same letters and that they're to the same powers. If you have same letters, same powers, you can combine them by combining their coefficients. Looks like this. What are my coefficients?
5 and negative 3.
5 and negative 3. We could say plus negative 3, but easier than saying that is 5 minus 3. So I combine the coefficients and I keep the variable. And this should make sense. If I have 5 of something and I subtract 3 of those somethings away, I have 2 of those somethings. On the other hand, just as a reminder from last week, if you don't have the same variable part, you cannot add and subtract those things, even if you have things that look like this. Like if I had 5x squared minus 3x, is this equal to 2x or 2x squared? No, you can't do that. It doesn't work. It's a problem. You have to have the same letters to the same powers, and then you can add and subtract algebraic terms. Okay? And likewise, that goes for constants. If you have something like this, where I have 5x plus 3 minus 2x plus 7, this is kind of foreshadowing the next concept. But what you can do is you can rearrange these things and put your like terms together, 5x minus 2x, and positive 3 plus 7, and you can add them together separately. So 5x minus 2x is 3x, and I can combine these constants because they're constants, like 3 and 7 are just 3 and 7, and 3 plus 7 is 10. So this would simplify, we use that word a lot, this would simplify to be 3x plus 10. 3x plus 10 and this thing have the same value. So if I said that x is equal to 5, and I tell you plug in x equals 5 here, you'll get the same answer if you did this. Okay? They are equivalent expressions. They'll get the exact same thing. It's just easier to work with, right? Like what would it be? Well, 3 times 5 is 15 plus 10. If you plug x equals 5 into this expression, you will get 25. You just will. They're equivalent. You could do it right now if you wanted to. It'd be 525 minus 10 is 15, plus 3 plus 7 is, 25. So it does work. Make sense so far? We can combine like terms when we have the same variable part, same letters to the same power. Let's try a couple of examples here.
Is this anybody's or is it just you? I don't know, it sounds something like you do.
I have one on machines lot, but I don't.
Why don't you open up your textbooks to page 95?
It could happen.
And we're definitely going to go through everything that's important in this book. And yeah, most of the first book is very important, so yes, we will.
Oh wait, are we gonna go up to an hour 30 today?
Yes, we are.
Okay.
I'll be out of here.
Mom, because they forgot to.
Okay.
Okay.
Okay, so I want you to do example number 1, A, B, and C. All 3 of those. Actually, do try it number 1 so that you can't see the work, like just right there in front of you. Okay, try it. Number 1, A, B, and C. I'll write them on the board. Are we still recording? Yes, we are. It's okay. Okay.
All those things in chat, we're gonna do these Sunday, at 1 for an hour.
Who's doing it? Jonathan?
Me.
Oh, I'm sorry. I was eavesdropping, but I heard D&D, and I was like, oh, that's cool. That's really cool. You guys are getting together on your own.
I've been trying to make campaign.
That's awesome. Do you have an idea for your own story?
Yeah.
Are you going to have the same characters, or are you going to make new ones?
I'm not gonna force them to make new characters because that would take too long.
Yeah, it would definitely, if you only have an hour, then probably a smart bet. Okay, let's take a look. So the first one, are these all like terms?
Yes,
And how do we know that?
because they're not two and
Well, and they have the same letter, right? They're all T's.
yeah.
Okay, so what we can do is combine the coefficients, and it looks like this. We're going to take 5 plus 6 minus 7. And whatever that answer is, we're going to throw that in front of our T. 5 plus 6 is 11, minus 7 is, what's our answer?
14.
4T is correct. Okay, next one. Are these like terms?
Yes.
Yes, they are. They have the same letters to the same powers, so they're like terms. Okay. Think of that variable part as just like one extra piece. Okay. As long as it has the same letters to the same powers, you can combine the coefficients. What are the coefficients?
-4, -3, and
5 and 2.
And plus 5/2. Oh, okay. What do we get? -4 minus 3 is what?
-7.
-7 plus 2.5 is what?
5, or
And by the way,
4.5.
I can go ahead and just,
I thought.
it is -4.5.
I messed up the first part.
So what you can do is this. We have it here. Let me be consistent here. So this is our problem. We need to do -4 minus 3 and then add 5/2. You can convert 4 and -4 and -3 to fractions with 2 on the bottom. 4 is 8 halves. So -4 is -8 halves. And -3 would be -6 halves. And notice how I'm using negative and minus kind of interchangeably.
Yeah.
Okay,
Virtually the same thing.
they're virtually the same thing in this context here of adding and subtracting. Okay, so and then we're going to take this and do 5/2. And our answer is going to go in front of our BZ. Let's see here. -8 minus 6 is -14 plus 5 is -9/2 BZ. And this is how you should write this. There's a couple ways you can write this. You could write this as -9 BZ/2 or -9/2 BZ, but don't put -4.5. We don't use mixed numbers ever as coefficients.
Yes.
Okay? You could say -4.5. You could convert to a decimal, but not -4.5. And the last one is what?
And
Not in.
0.
0. If the think about this. Okay, so this is what we're doing. We're doing 3 minus 8 plus 5. 3 minus 8 plus 5. 3 minus 8 is -5 plus 5 is 0. Now, I know what you're thinking. Oh, 0 cancels out, so I'm left with n. Now, that makes sense, but remember that the number in front is multiplied, and 0 times anything is 0. So this is 0. In by itself, oh yeah, this is another point I should have made under section A. But if you have a variable by itself with no sign in front of it, the coefficient is 1. Okay? Because you wouldn't write it down if there were 0 of them, right? Okay. Very good. Moving on. I think I'll copy this and put it on its own layer. Okay, let's do some more, just a couple more examples. This is example 2. I'll work some of these out. Now, I'm going to show you some, the reason why. So I told you in the beginning, I said I wanted you to, when you had things like this, I said think of this coefficient as being -2y. And here's the reason. If you have this, 5 minus 3, can I just move these around and say, oh, this is 3 minus 5? No, that doesn't work. Subtraction is not commutative, okay? The order matters. But could I do this? Could I say 5 plus -3 and then switch the -3 over here? Yes, you can. These are the same answer. Addition is commutative. So when I say for you to think of this as being negative 2y, I'm asking you to think of it like this. And the reason why we do that is so we can move the terms around and combine them with like terms. Okay? So this is example 2 on page 96 up at the top, and we have an expression that looks like this. 3a plus 4b minus 2a plus 5b. Now, the reason why I tell you keep negative signs with their terms is because we're not necessarily subtracting something from 4b. Bless you. This negative 2a can be moved around as long as I take that negative sign with it. Okay, so what I'm going to do is this. I'm going to go over here and I'm going to rewrite this as 3a minus 2a. Now, why am I doing that? Because I am combining like terms. I want things that have the same letters to be next to each other so that I can do that operation and simplify. Now, what do I have left? I have a positive 4b and a positive 5b. So I'll combine those like terms. 3a minus 2a is, which is just a, and 4b plus 5b is 9b, and that's the answer. So does that make sense now? Like why the negative sign in front can move around? That's why I want you to think of this whole thing as being negative 2a. Because a lot of people, it's intuitive to them that they see this and they look at it here. And they think, oh, well, I'm subtracting something from 4b, I must subtract 5b. And that is wrong. Well, I mean, here's the wrong way. Here's the Colin way. Now, you people, by the way, for posterity, there is no actual Colin. There's not a student in my class named Colin that I make fun of, okay? It's a character that I made up that always does the wrong thing, all right?
And so probably learn better because of Colin.
Yes. Sometimes you learn best by seeing what not to do, right? It's like the Berenstain Bears, the dad. Do you ever read those? The dad is always making a mess of things. He always does the wrong thing. Now, unintentionally, yeah. What? You know, he has very influential parents.
Yeah.
All right, so anyway, what some people will do is this. They'll say, okay, well, 3a is going to be plus 2a because this plus sign tells me that I'm adding to 3a. And 4b is going to be minus 5b because 4b must be subtracting. I'm reading this like a sentence, which is intuitive if you haven't had like training in algebra, right? It's intuitive to read things left to right, but it's wrong. This is not 5a. You couldn't be more wrong. I guess you could, but not reasonably. Okay, so signs in front of terms belong with those terms. We keep them together. Okay, I want you to do try it number 2, A and B, and then we'll move on. Whoa. There's just a very powerful spring on this lid closer. With this boom. Yeah. I'm drinking here.
You better watch out, this water for something I can't see if I'm walking.
I love this water bottle. I stay hydrated more consistently.
You know what I'm gonna start doing? I'm just gonna grab like, I have the ton of them, just like gallon containers, and just fill them.
Well, the problem with regular like gallon jugs is that they're hard to clean.
That is true.
They're so hard to clean. You get a gallon water bottle and it just gets, funky after a while.
Assuming your dominance makes up for it though.
Yeah, well, I can assert my dominance with this and also be hygienic,
Yeah.
okay?
Thing is,
Because the whole top screws off and you can fit your hand in and scrub. Okay, what did you get for try it number 2A?
2C minus 3D.
Minus
3D. No, just
minus 5D. Negative 4 minus 1 is negative 5.
mask is.
Oh, dang.
I'm going to go ahead and do that one on the board because it sounds like we all missed it. So let's just get some practice. 5C minus 4D minus 3C minus D. Okay, now there's a lot of negative signs. As long as you keep them together, it'll be okay. 5C is going to go along with minus 3C, and negative 4D is going to be minus 1D. 5 minus 3 is 2C, and negative 4 minus 1 is negative 5D. And that negative sign, the answer to this problem, when you combine your like terms, is the coefficient. So if your answer is negative, you just put a negative sign. You put a subtraction sign in between, and that's your answer. It's really 2C plus negative 5D, but we don't need to write that. Please don't write that. That's confusing for a reader. Okay, it's just 2C minus 5D. All right, try it 2B. Yeah.
I got 3ax minus 5x plus 3 over 2 plus 1/5.
Well, okay, two things. Negative 7 minus 2 is negative 9.
I'm gonna ask negative 2.
Well, it is. It's negative 7 plus negative 2, which is negative 9. Yeah.
My mind just like saw the subtraction sign, and I just thought like.
Wipe everything you learned in preschool out of your mind right now.
No, because I thought it was like minus negative 2x. So.
Oh, yeah, I see what you're saying. Yeah. Okay, next one. 3 over 2 minus 1/5. What's that?
Wait, there's another one.
13 tenths. That's correct. Good job. So, and is that positive or negative 13 tenths? Positive. So it would be plus 13 tenths. So the final answer is 3ax minus 9x plus 13 tenths. That is correct. Okay. We love combining like terms.
Yay! Except when they're negative.
I think I'm just going to actually hide these and we'll start fresh. So we love combining like terms, but we have combining like terms is it's like Romeo and Juliet. They saw each other, they knew they were destined for each other. Well, actually that's bad. That's a bad analogy because they were from, the Montagues and the Capulets were not like terms. But they wanted to be together. Something can get in the way of that. Parentheses.
Oh, parentheses is just straight death. And trapped.
Parentheses can cause a problem. I'll show you how. Sometimes we want to add things together, like this. So if I have 2a plus 3b here in parentheses, and I have a 3 out front, what's this 3 doing? What operation?
It's multiplying.
It's multiplying, yeah. And then over here on the other side, I've got 5a minus 2b, but I have a 2 in front of these parentheses. Now, these a's want to be together, and these b's want to be together. And that's a problem, because they can't. You know why?
Because
Because, yes, exactly. Whoa, yeah, this is like Romeo and Juliet. Yeah, exactly. They're the parentheses don't want them to be together. Okay? Now, and, so what do? Well, just like in Romeo and Juliet, we attack the parents. No, that doesn't actually happen, I'm pretty sure.
break down the walls.
You break down the walls, exactly. How do we do that? So mathematically, what's happening here is we have some multiplication that has to happen first. I can't add 2a plus 5a because this multiplication has to happen first. This is where we use the cat claw.
Yeah.
That's right, the cat claw. You've heard it because you've had a sibling go through my math class. But what we're going to do is, here's the cat. Why do I call it a cat claw? Because it looks like this. And also you have to make the noise when you do this, otherwise you fail.
It never ended.
What do you
Literally, my brother was doing his homework. So annoying.
Imagine just creeping up.
It's a cat claw, okay? It's a cat claw scratching through. Now the cat claw represents distribution. A property of multiplication is if you're multiplying a sum in parentheses like this, you can get rid of the parentheses by multiplying the number outside times both of the things that are being added inside. Now let's replace this with regular numbers so you can see that this makes sense. If I were doing 5 plus 1, so I'm going to draw this out. Okay, I'm going to draw this with like unit blocks. Here's 5 blocks, and here's 1 block. I guess I don't need to shade them. And multiplying by 3 means I'm going to take this and I'm going to put it together. 1, 2, 3 times, right? Isn't that multiplying by 3 is taking 3 groups of that thing? Yes. Now, first of all, what is it? Do this using order of operation. Order of operation says, oh, add these 2 things together to make 6 and then multiply 6 by 3. Well, I think you can clearly see that there are 3 groups of 5 and 1 here. So what distribution allows us to do is to say, oh, I can do this without combining 5 plus 1. I can say that 3 times 5 is 15, and 3 times 1 is 3, and then I can just add those things together afterwards. Okay? Now, you wouldn't need to do that with this problem because it's arithmetic. But here, you can't combine 2a and 3b because they're not like terms. But you can get rid of parentheses by distributing. Okay, so when you have 3 times 5 plus 1, we can rewrite this as 3 times 5 plus 3 times 1. You can separate the addition problem and multiply each addend, is what they're called, by this number in front. Okay? So that's what we're going to do. We're going to multiply 3 times 2a. What is 3 times 2a?
5a.
That's
6a.
6a. When you multiply a constant times... we haven't done this a lot. So this is actually a good time for review. If we multiply a constant times a variable term, you multiply the constant times the coefficient. So, and let's think about why. What is 3 times 2a? Well, remember that 2a means 2 times a. What's 3 times 2 times a? Well, 3 times 2 is 6 times a is 6. Okay, 6a. No, 6a is still 0 if a is 0. Yeah, it would only be division where you have to say like if. Okay, so this is going to be 6a plus 3 times 3b is 9b plus 2 times 5a is 10a plus 2 times, what's 2 times negative 2b?
Negative 4.
And that's what we're going to write down, 4b. And that's what we're going to write down as negative 4b, which is really just minus 4b. Now that the parentheses are out of the way, these A's and B's, these Capulets and Montagues, are free to intermingle. Okay? So this 10 and this 6 are going to want to be together. My darling. And this 9b and this minus 4b are going to want to be together. Okay? So that's what we're going to do, is put them together. 6a plus 10a is 16a. And 9b minus 4b, and by the way, I should have a plus on here. 9b minus 4b is positive 5b. And this is the simplified expression. We got rid of the parentheses, we combined like terms, and that's what we did.
Yay.
And by the way, if I tell you A is 2 and B is 7, you could plug that in here, and you could plug that in here, and you would get the same result. These are equivalent expressions. One is just a lot easier to work with, right?
Mm-hmm.
Yeah, this one's a lot easier to work with.
Yeah.
Spoiler alert, it's this one. Okay. So that's how we deal with parentheses, is we distribute the thing that's out in front of the parentheses. If there's nothing out in front of the parentheses, like if I just wrote this, 2a plus 3b plus 5b.
Multiply it by 1.
Yeah, it's basically a 1. It doesn't matter. It's you can get rid of the parentheses.
Yeah.
You just boom, you just swap them out. Now, on the other hand, if there's a negative sign in front of your parentheses, you have to distribute that as well. So here's an example here. And this is something you see a lot when you're just subtracting expressions. So if I had, let's do x's more. So if I had 5x minus 7y minus 6x plus 3y. Well, now let's think about what that means for a second. Let's think about this. You know, sometimes when you're doing something that's abstract and algebraic, it helps to take a step back and look at what you would do in the arithmetic case. Like these were just numbers. So if I had something like this, if I had 5 minus 10 plus 2, okay? Let's make this even bigger. 10 plus 12. Would I take 5 and subtract 10? Oh, that'd give me negative 5. And then add 12?
No.
No, because you're taking away a big number, the sum of things. So what do you think we would need to do to this negative sign? What do you think we have to do with this subtraction? You have to subtract them both. Right? Yeah, you have to subtract them both. You have to subtract 10 and subtract 12. Okay? In order for this to make sense, because I'm really subtracting both 10 and 12. Okay, so anyway, looking at this in the algebra context, I'm going to subtract 6x, and I'm also going to subtract 3y. Now these parentheses over here, I didn't even really need to write. Because there's nothing in front of them, no symbol, like no multiplication going on, I really don't even need these parentheses, but you'll see this a lot. Okay. But we do need to distribute the negative sign. And what does that do? It changes the sign of the things inside. So a negative 6x just means that I'm subtracting 6x, and a negative times a positive 3y is minus 3y. So having a negative sign out front just changes the sign of whatever you have inside.
Okay. It's like multiplying by negative 1?
It is. Yes, it is. Absolutely. So what do I do now? What's it called? Combine like terms. And by the way, you don't always need to write it down. You should in the beginning, but once you get a knack for saying like, oh, I need to subtract 6. This is 5 minus 6. That's minus 1. This is how I do this, by the way. I look at the terms, I do the math, I write it down. 5 minus 6 is negative 1, so I have negative 1x. Negative 7 minus 3 is negative 10y. And that's it. Yay. Okay, one more example. Okay, I'll just keep this up here. Let's see. I'll take this one from the book, actually. let's look at, it's gonna be great.
It's gonna be fun, especially since last time you guys were my parents work on Wednesday and I just couldn't.
Oh, yeah, I've been doing like.
This is actually from your homework.
Oh, yay, free homework answers.
Oh my goodness.
This is number 2F. And the problem is -7 times 2R. Oh, it's on page 106. -4 times -3R minus S. Oh my gosh, look at all those negative signs. And believe it or not, yes, we are going to combine this down to just two simple terms.
Yay!
So here's what we're going to do. What do you see that gets in the way?
The parentheses.
Parentheses. So yes, we are, and how do we get rid of those?
Distribute.
What?
Distribute. The 7.
Called the cat claw.
Oh yeah.
You are correct, writing it as distribution. It's called, in my class, it's called, we need the cat claw. In fact, it was dubbed the cat claw strike because it is kind of a violent move. Okay? It's like a kung fu move. Well, I shouldn't say that. It's like a kung fu panda move. Let's say that. All right? So,
Yes.
so get some aggression in your voice. I can't do it with I can't aggressively rant. Okay. So -7 times 2R is
-14R.
very good. -7 times -3S is
21S.
positive, and make sure, so if your answer when you're doing these intermediate steps is positive, you put a plus sign on your term. -7 times -3S is plus 21S. -4, when you're distributing this, when it says -4 times parentheses, you have to multiply by -4. Just like coefficients, you keep the sign, like that's the thing that you move around. When you're distributing -4 here. -4 times -3R is?
Positive 12.
Positive 12R. -4 times -S is?
4S.
Positive 4S. Now notice I wrote down a sign for every one of these. And now we can rearrange things so that I have the letters together that I want. We have -14R plus 12R plus 21S plus 4S. What is -14R plus 12R?
-2R.
-2R. 21 plus 4S is positive 25S. Whatever your answer to these questions is, that's the sign you put in front of that term. If your answer is positive, you put a plus sign.
It looks so much easier than the original problem.
Oh yeah, it definitely is. And that's why we do it. That's why we do it. Technically, yes. Yes, you may.
Bye.
All right, let's see here. You guys, I want you to just write this down. You can scan this. You can actually put it on a fresh piece of paper because it is going to be part of your homework. So you can just start working on page 106, number 2. And I just did 2F for you.
Okay. Just gotta remember that. I gotta copy it down to my Google Doc.
It's gonna take
Yeah.
a while.
Yeah, I know. We're just doing this while Braden goes to the bathroom.
The first problem is not it. Are you gonna try to go to the DD session or?
What is it?
Sunday one. Yeah, I can change it if I'm.
I'll see. say no.
My dad used to have a pen that had a button, and when you pressed it, it would just yell no at you. In like different ways.
It's an easy button. I worked on this machine, and we went to a store to go buy a Switch, and my dad had to give we had to make an account to buy something there, and when we made an account, and he had to give his name, and the guy was literally like, "Come on, Raj, I was nice to you, I even got a screwdriver for you to open up your Switch to see." It was like, you just give my dad time, it's an $80 Switch. Like, come on. There's something about the homework.
Yeah, I assigned number two on page 106 just while you were in the bathroom because I didn't want to need any real downtime. Okay, and we're almost done with chapter 4.
Yay! That was fast. I was still ready to go. Oh, is that clock wrong again?
Where is his watch? I do. 1:49.
It's right, but it's off by a minute.
It's right, but it's not right.
It's right, but it's right enough. How about that?
That's right, I don't hear very many rares.
So mean.
Are we doing all of the problems in 2?
Yes.
Okay. Technically, we can skip one. Nope, I'm not doing that.
Oh, 1? Yeah, 1 is kind of like you're doing number 1 when you do number 2.
Yay.
So I'll go through and I'll remove the ones that I think are
Unnecessary.
yeah, unnecessary, superfluous is what I was going to say.
Superfluous? I learned the word.
Wait, so expand the following. Expand.
Which one? Oh, expand means get rid of parentheses.
Yeah.
Get rid of the parents.
I thought it meant like simplify, but like the opposite. Make it bigger.
Yeah, simplify means that there's terms that can be combined.
Yeah.
Okay. Any questions on parentheses?
No.
All right, let's move on. You guys.
Oh, man,
Well, okay. Let's just check. What did you get for number 2A?
I'm still doing it.
Okay.
Wait, did you say it?
Okay.
Good.
7x plus 43.
Plus 43 is correct. Okay, great. Quick check-in. Moving on. We have other things we don't like.
Yay!
The other thing that we really don't like is fractions.
Oh yeah. No one.
Now, you already dislike fractions when they're just regular fractions, but when you start seeing fractions that have variables and letters in them as well, I think you're going to hate fractions even more.
Like 5a over 2.
Oh, even worse. We're going to have things like this. In fact, this is example 11. 3x minus 4 over 4 plus 2x plus 5 over 3. And what you need to do here is you need to combine like terms. Let me just say that again. You need to express this as a single fraction in its simplest form, which is going to involve combining like terms. Now, it is a fraction, so what do we do with fractions when we want to add or subtract fractions? We do, actually, we need a common denominator.
Common what?
Oh, it's gonna be a pain.
Fun. I wonder how many hours I can spend on this procrastination time. Longest time wins.
Okay, so we are. What is the common denominator? 12. So, It's 12. How did I get 12?
You multiply the 3.
I multiplied this one on the left by 3. So I'm going to show you, I'm going to do this on the original problem here. To get a denominator of 12, that means I need to multiply the top and the bottom by 3. Okay, so 4 times 3 is 12. That's easy. That's how we got 12. What do we do to the top? Well, we're going to distribute that 3. Okay? You have to consider, and this, by the way, if you remember this, it'll help you, prevent you from making a lot of mistakes in this, is if you treat this thing that's in the top of the fraction as something that's in parentheses every time, you won't go wrong. You remember me saying how a fraction is like a grouping symbol and that, you have to do the two things separately, like you can't, cancel out the 4 here. So if you treat the thing that's like the top and the bottom of the fraction separately, like it's something that's in parentheses, then you'll always get your answers right. So I have to distribute this 3 to the 3x minus 4.
9x?
It would be 9x minus 12. And over here, what am I multiplying by?
4. 8x.
So I'm going to multiply the top and the bottom by 4. That's going to give me 12 on the bottom. So that's going to give me 4x plus 20. Now, I'll be honest with you. I wouldn't write this step.
Wait, no, it's 8x.
I wouldn't write this next step, but I'm going to in this case here. Is it?
It's 8x.
Yeah, thank you. So I would not write this step after, because I've done this for a while. You guys, once you get comfortable, you don't need to. But what we're going to do is we're going to take these two separate things, keep them in parentheses, 9x minus 12 plus 8x plus 20 over 12. So basically, again, just like we did with rational numbers, all you need to do now is combine like terms on the top. And whatever your answer is, that's what stays over 12. Okay? Now, because I have a plus sign here, plus sign is like saying positive 1 times. So I can actually just get rid of these parentheses. And I can get rid of these parentheses because there's nothing in front of those parentheses. But like I said, if you do this, if this had been a minus sign, you'd be distributing here.
Yeah.
That's why I say, just keep it like it's in parentheses. 9x plus 8x is 17x, and negative 12 plus 20 is positive 8. Now this goes over 12.
Oh, that was surprisingly easy.
Yeah.
Are they all the
We
same,
still
or
hate
is
factors.
Mr. Warren's one?
Yeah, well, here, I'll give you one that's not as easy.
Sophia. Are they
Why
all?
is everything like
I have to be.
It just is.
You have to be big brain.
Mr. Warren. I know he's math.
I know your games, math
Mr.
teacher.
Warren.
The easy ones for the examples.
I know your ploys. All right, here we go. So we've got 1 minus 2x. By the way, this is example 11b on page 105 if you care to follow along. 1 minus 2x over 3 plus 3x plus 1 for 5 minus 4x minus 3 over 6.
Whoever wrote this is going to.
I knew there was a caveat.
Oh, wait, never mind. It's just this time.
Okay,
Yay.
first of all, I have 3 fractions now, and I need common denominator. Ooh, factor tree, we have 2 primes and 6. I don't think we really need a factor tree. So 3 is already a factor of 6, so you can ignore 3. What's the least common multiple of 5 and 6? 5's prime? 30. So that means that I need to multiply this fraction by 10. Now, okay, if I were showing you every single step, it would look like this. I would say, I am multiplying this by 10. I'm multiplying this by what?
6.
I'm multiplying this by
I'm pulling a yawn.
Or
Like 5 hours straight.
Oh, because of fireworks or?
Yeah, fireworks my neighborhood, they were going until like 11:30. Loud.
Oh, mine were going easily 2 a.m.
Really?
2 a.m. I woke up at 2 a.m. to a boom. Just literally just
Man, yeah, I was like, okay, if there's a firework after midnight, I'm gonna go out and
The
talk.
problem was it's not even in my neighborhood. They have such big fireworks. Literally, even in the darkness of night, you would see the cloud of smoke.
Yeah.
Like, they're illegal fireworks. I woke up at 2:30 in the morning.
So the craziest 4th of July I've ever had in my life was in LA. I lived downtown, and my brother he actually lived in an apartment that was in a shopping center above a Chinese restaurant. Okay, so there was a Chinese restaurant on the bottom, and then his apartment was above that for some reason. I don't know. So, but he had roof access. So on 4th of July, 10 o'clock or whatever, or whenever it got really dark, we got to the top of the roof, and it was just a 360-degree firework extravaganza that went on for like 4 hours nonstop. Just boom, 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 boom from all angles. Like downtown LA goes nuts. Yeah, it was 360 degrees. It was a panorama. Just everywhere you looked was like a full-on fireworks show. It was insane.
Yeah, but last Fresno was crazy because everybody's crazy.
Yeah.
And literally just it gets dark. Everything's quiet. And then it turns into sounds like there's a war happening.
Yeah.
It's literally everywhere. You just see bright light in the sky.
Mm-hmm. All right, so let's continue on. We did completely interrupt this problem. I should have waited until we finished this problem. But here we go. Okay, this problem, we're creating a common denominator for all three of these fractions. We need to multiply each fraction by something different so that we get 30 in the bottom. The first fraction we're multiplying by 10, and I need to distribute that 10 to both of these terms, the 1 and the negative 2x. That's going to give me 10 minus 20x. Plus, and you know what, save yourself the trouble right now. You can just write down that each one of these fractions has 30 in the denominator. Now, I'm adding the first two and I'm subtracting the last one, so that's really important. 6 times 3x plus 1 is 18x plus 1.
Wait.
Plus 6. Oh, good. Oh, you caught it. Good. Very good. That is correct. And here, 5 times 4x is 20x and minus 15. Okay.
No, you can't simplify.
You actually could simplify these fractions right now, but that would be counterproductive because we need the common denominator. If you simplified them, guess what? They would go back to this. They would go back to their original fraction.
Yeah, let's go simplify.
Let's go back.
2 steps forward, 2 steps back. So now we're going to combine like terms. It looks like this. Remember I said always put these things in parentheses, like so, plus, like so. 18x plus 6 minus 20x minus 15. Now this is all going on top of one fraction as a denominator of 30. Now I don't want to rewrite this whole thing again, so I just want you to take a look here. Can I get rid of these parentheses?
Yes.
Yes, there's nothing in front. There's a plus sign in front of these parentheses. Can I just erase these?
Yes.
Okay, now how do I get rid of these parentheses? Yeah, exactly. What am I distributing? The negative sign, which is like Sophia said, it's like you're multiplying by -1. So -1 times 20x gives me minus 20x.
And then plus 15.
and plus 15. Very good. A negative times a negative is a positive. So that negative sign that was in front of the parentheses, oh, you know what? Why am I doing this? I can copy and paste.
Yeah.
You guys don't need to write all this down.
I wish you could do that with writing.
Just like grab it, pick it up, and put it somewhere else.
Like, that would make taking notes and writing and everything so much easier.
All right, so take a look here. So yeah, distributing this negative sign here, is going to give me minus 20x plus 15, and that's it. Now I can combine my like terms. And again, I mean, I don't want to rewrite this thing every single time. Let's look at our x's. I've got minus 20x plus 18x minus 20x. That's a total of negative 40x plus 18.
Negative
20.
2x, very good. And then I have 10 plus 6 plus 15
31.
plus 31. This is all over 30. And you can check, you can see the work. It's a lot. It's a lot. And there are equations like this where there's even more. So
Now imagine plugging in a number for every x and then doing the problem.
oh yeah, like doing a problem in the beginning and finding and then doing the common denominator and all that. No, you can do it all at one time.
What would be the point of doing that?
I mean,
Plug in
that happens
everything with
sometimes.
one and delete all the variables and then only put them manually.
Okay. Hey everybody, that's chapter 4.
Yay!
And we have almost 30 minutes. We have 25 minutes to do algebra.
Yay!
Now,
That didn't happen.
I'm tired. I don't know why. I think it's because I woke up at 2 a.m. and like stayed awake. Like I was like that half sleep, half awake.
Our neighbors were setting on fireworks really loud, but they ended at like 10, so it's fine. But I couldn't sleep until like 10.
My neighbors said that like if we live the same neighborhood, it's probably me and my family because we had school fireworks.
Okay, take a look. Now we don't have a lot of time, so I do have to just rush through here. And let's just talk about, by the way, equations is often abbreviated EQN. So equations, and what do we do with equations? Equations, now let's just contrast this with everything we've done up to this point. An equation has an equal sign. So it looks something like this. X plus 2 equals 5.
Wow.
Now, this is a statement that is telling you that two sides are equal. So there's a true statement here. It's saying that it is true that if you take x plus 2, your answer will be 5. Okay? All right, we'll get to that in a second. But what I want you to understand is that unlike those other expressions where the variable didn't have a value, if this is a true statement, we can find out the value of x that makes this true. That is called a solution. So equations give us something that we want to solve. We want to know what makes this a true statement. And you're saying, oh, well, this is 3, obviously, right? 3 plus 2 is 5. And it is obvious by looking at it. But we also need a method of solving these equations.
Subtract everything from both sides.
Whatever, right?
Subtract everything.
Now there is some number, one number, only one, that makes this equation true. Okay? Do you see my point here? Is that we need a method that is more than just inspection. That everybody, we're going to learn methods that are going to give us kind of an algorithm for solving these equations. Okay? And that's our goal, is to find out what number can I replace the variable with to make this a true statement. Okay? That is the definition of a solution. Solution. Abbreviated as SOL in a number that makes an equation true when substituted, I'm going to abbreviate that, for the variable. Variables, actually. You can have multivariable equations that you can plug in different numbers for the x and the y and the z to make it a true state. Okay, so that's what a solution is, and that is what our goal is. And you know, it's really easy when you look at this right now to say that x is equal to 3. But like I said with my other example, sometimes it's not so easy. So what we need to do is we need to change the way we think about these, because I know that you've done a lot of number needed in like 3rd and 4th grade when it was just, you know, oh, I'm just going to do like an addition or subtraction problem and I'm going to answer this question. But we're going to be doing some more complicated algebra that requires a different method. Let me go ahead and put this up real quick. I'm actually going to just go to GeoGebra. I've heard some people call it GeoGebra. Yeah, I mean, it's obviously like an amalgamation of geometry and algebra.
I mean, who can't? Ooh, flood in Miami.
Oh my goodness. This is a new like evil game.
No, there's actually a very cool math activity that I didn't do with you last year.
Aww.
You should do it with us
Now.
Right now. This is what I hate about GeoGebra, is that it does not have a good search function. Like I could type in right now, there it is. I could type in algebra scale and it won't.
He's gonna be like, here's searches for.
It'll give me somebody else's algebra scale. Not my own.
Algebra scale.
Okay, so what we're gonna do is we are going to think of, oh, you're kidding me.
It's like, nah. It's like, you can look up this other teacher from a completely different country.
Please don't tell me that this is broken. If this file is broken and corrupted on there, okay.
Yay!
All right,
2x
let's,
plus 4. Wow.
It's so difficult. I wonder what 3x plus 4 is.
Oh,
Okay.
That's right.
hey.
Now,
That's not right.
okay. Yeah, how do you know it's not right by the picture? If I do this, how do you know that this is wrong?
It's not valid.
Now, in equation, this is the key to understanding this concept. The equation is like a balanced scale. The value of the thing on the left is equal to the value of the thing on the right. That has to be true for you to be able to solve it. Okay? So it's like a balanced scale. Now, if I asked you to find out how much, can I write on this? If I want to know when you're, don't do that. I guess we can go here to the pen. If I'm asking you, how much does this X block weigh? We can figure that out on the scale. How do you find out how much something weighs on a scale? If I gave you this and I said, figure out how much this thing weighs, and I gave you a bunch of weights that you did know, what would you do with a scale like this?
You would put this on one end and put the weights on the other.
Exactly. You would get this unknown weight by you would get this unknown weight by itself on one side of the scale, and you would get a known weight on the other side. And that's exactly what our goal is in algebra, is to get the variable by itself. You want the variable by itself, and on the other side, you don't want any variables. You want a constant. Okay? So that's our goal. Okay, so, well, that's easy enough. Why don't I just, I'll just take these 5 off. Here we go. I'll just take these 5 off. 1, 2, 3, 4, 5. Oh, there we go. It weighs 7.
Totally.
What did I do wrong?
If the scale is balanced.
Oh, when I take things off of one side, when you have a balanced scale and you take weight off of one side only, the scale becomes imbalanced. So what do I have to do?
You have to take the same amount off the other side.
You have to take the same amount off. I could do this, right? I could take the same amount off of either side until I reach this situation here where I have the variable, the unknown by itself on one side and the known value on the other side. Now that's exactly what we do. Now this can be, now I'm not going to ask you to draw a scale and do this every single time. And by the way, this doesn't work very well. And this picture doesn't work that well when we start talking about negatives and things like that. But what I want you to understand from this demonstration, is that an equation is just like a balanced scale. You can do whatever you want to manipulate the equation pretty much, as long as you do it to both sides of the scale. I could double both sides of the scale. So if I double the left side, I would get 2x, and I could double the right side to get 4, and that's still a balanced scale. Okay? And I could divide as well. I could cut this into, 20 equal pieces. If I cut these 4 blocks into 20 equal pieces, that would be true as well. Okay? You can add and subtract to both sides. You can multiply and divide. Things don't get tricky until you can multiply, you can divide as long as you're not dividing by 0. Obviously, you can never divide by 0 and get a real answer. Things get a little bit trickier when we start taking square roots, but we don't need to worry about that. For us, all you're ever going to be doing is multiplying, dividing, adding, or subtracting. And if you multiply or divide or add or subtract, you can do that to both sides of the scale. You can do that to the equation as long as you do it to both sides. Okay. Now that we know that, let's think about solving equations in a different way. Our goal is always to reach this step right here, where you have the variable by itself and k means some constant on the other side. So what I do is I think of this as kind of like, I'm just going to tell you how I think of it. It's going to sound creepy, but it's kind of like getting dressed and undressed. When you undress, it's like we're undressing X. I'm sorry, I have to say it. That's the analogy. We're undressing X, okay? X has clothes on. So it's like this. When you get dressed in the morning, and let's just say you're putting on your shoes, okay? Put on your shoes. Socks first, right? Shoes second.
No.
Shoes second. Does anybody put their shoes on before their socks?
How do they even work?
When you're taking your shoes and socks off, do you take your shoes off or your socks first?
The socks.
You take your shoes off first and your socks off second. So it's very, and I just stuck with the feet, all right, just to keep things as minimally awkward as possible. Okay. I think my point is that when you're doing this, you kind of do it in reverse order of operation. Anyway, let's just solve some very simple single step. Let's solve some very simple single step equations, and I want you to do this by thinking about getting the x by itself. It has stuff with it. We need to get rid of it. Okay. So here's an example. Actually, let's just work a bunch of examples.
Yay!
Here we go. X minus 5 is equal to 11. Now here's the way I want you to show your work. And also, because the way that you show your work really illustrates the way you think about the problem. Okay? I want to get the x by itself. So what I'm going to do is add 5 to undo this minus 5. Now if I add 5 to the left, am I done? No, I've unbalanced the scale, so I'm going to add 5 to the other side. These cancel out, and x is equal to 11 plus 5, which is 16, and that is the answer. And you could verify. How do you verify that that's a solution? Well, no, by plugging it back into the original equation and verifying that it's true. I'm not going to ask that you do that, because sometimes checking your work is longer than actually solving the problem, okay? So let's go to the next one. X plus 6 equals, I'll just change it, negative 13. What do I do to get the x by itself? Subtract 6. If I'm adding 6 to x and my answer is negative 13, I subtract 6 from x to see where I started. Cancels. Also, these are simple. These are one-step equations. We're going to be doing equations that are 5 and 6 steps. Every step you take gets closer and closer to the x being by itself. So if you start doing things to an equation and you notice that it's looking more and more complicated, you're doing something wrong. Okay? X is equal to negative 13 minus 6, which is negative 19.
As long as x doesn't have any socks on, you're good.
That's right. X equals 4, x over 4, sorry, is equal to 7. Now what does this x over 4 mean?
X divided.
Yes. How do we undo division?
Multiplication.
Multiplication. The inverse operation is multiplication. Also, look, this is why multiplication is multiplication and division is division. It cancels out, cross cancels. I have to multiply this other side by 4. X is equal to 7 times 4, which is 28. Negative 6x is equal to 8. What? Something times negative 6 is equal to 8? That doesn't make any sense. Oh, but it does.
Yay, fraction time.
How do I cancel this out? What do I do? What's happening to the x? That's a question you can ask yourself. By what?
Negative 6.
So how do we undo that?
Division.
By negative 6.
Yay.
And remember, division in algebra is often just fraction. You make it a fraction and then simplify. So the negative and the 6 cancel out. I'm left with x. And 8 over negative 6 is negative 4/3. That's it. That's your answer.
Oh wait, you don't have to make them mix.
No, we're pretty much done with mixed numbers for now.
Yay!
If this had been some sort of, real world problem that involved like cups of sugar or something, I would say, yeah, I would rather, if I'm doing cups of sugar, I want to know 1 1/3, not 3. But since this is negative, it doesn't really make sense.
I feel like I just haven't taken what's happening.
Okay, we're going to keep going. You're also going to see problems like this. And this is where the shoe analogy comes into play. I wasn't just being a weirdo. 2x minus 3 is equal to 11. Now, what's happening to x? It's being multiplied by 2 and subtracting 3. Now, order of operations says that I do multiplication first and subtract 3 second. But we're taking our shoes off. So we do it in reverse order. Like when you're putting your shoes on, you put socks and then shoes. When you're taking your shoes off, which is what we're doing, is we're getting back to what x was. Like, what does x have to be?
Order of operations.
Yeah, so do it in reverse order, basically. So what I'm saying to you is, get rid of this 3 first. Add 3 to both sides first. And what happens to both sides of this equation? Well, can I add? Is this 5x now?
No.
No, because adding 3 is not a like term. It only cancels out the negative 3. 2x is equal to, and this cancels, 11 plus 3, which is 14. Now what do?
Divide by 2.
That's right.
For both sides.
And x is equal to 14 over 2, which is 7.
7.
Now, you could start this problem off. Here, I'll do it over here, and you can see how much more complicated it becomes.
Yay!
You could say, oh, well, x is being multiplied by 2, and since that takes precedence in order of operation, I'm going to divide everything by 2. But if you do that, you have to divide this whole side by 2. Which means that you need to divide this by 2 and this by 2. And then you also need to divide the 11 by 2. Okay, now this does cancel out. So this is x minus 3 halves is equal to 11 halves. And then you could add 3 halves to both sides, and x is equal to 14 over 2. Like, I guess it's not that much more complicated, but if you don't want to deal with fractions ever, also, there weren't any fractions to begin with. If there were, this would be a lot more difficult. Okay? So don't do that.
No fractions were hard to
Take your shoes off first, and then your socks.
Don't rip up your socks with your sharp toenails and then bring it all the way up.
Okay, here's another one. That would be,
You still wouldn't be able to take it off though, you have to like cut your socks.
Just every time you take off your socks and shoes, you need a new pair of socks and shoes because you sharpen your toenails to a point so that you can get through every time.
You're just walking and you just like pierce through your shoe.
I mean, maybe if you were, honestly, if you had socks on those sandals, maybe you could like yank your sock over your
But
toes.
also, it's a crime to wear socks and sandals.
No,
It's all
That's
How dare you?
misinformation. That's propaganda. You can wear whatever you want. It might not be cool. I'll bet if some 19-year-old rapper with a bunch of face tattoos just started wearing socks and sandals, like, it'd be like, oh, yeah.
It's still an unholy.
Did you know that Justin Bieber got blacklisted from ever buying a Ferrari ever again in his life? Because he forgot where he parked it.
All right. Let's move on. We have 5 minutes.
Ferraris.
Unfortunately, I wanted to get to more, but I think that we're gonna have to stop with exercise 5.1. Let's see how far. I'm gonna work one more example. What do you notice here that's different from the other problems?
The constant
It has-
is not a constant.
It has what?
It has variables on both sides.
Variables on both sides. That's what I would say. But look back here. Like, would this be a problem? Is that a problem?
No.
What's the solution to this problem?
Subtract the 3x from both sides.
You just take off the 3x's from both sides. Okay? So variables are just like constants. You can add and subtract whatever you want to both sides. If I see a problem like this, the first thing I do is I think, I want to get my variable to one side. And I'm going to do that by subtraction. So which side do you want to get rid of?
The right.
It honestly doesn't matter. I would get rid of the...
Flip it around.
You could. You can. You can say, like, if A equals B, then B equals A. Okay?
Wow.
It's the transitive property of the equality. Anyway, yeah, so it doesn't matter which one you do. I would actually say that you get rid of the side that has less x's, because then you'll have a positive number that you're dealing with. If you subtract 7x, then you deal with a negative number, and that's just one more thing that you could make a mistake with.
Yeah.
If you subtract 2x, then you're kind of safe.
And then you borrow these.
Cancels. Negative 3 is equal to 5x minus 18. What do I do next?
Wait, but
What?
that's multiplication. You can't
What do
You
you
can subtract.
No, you
You
can
can
because it's
subtract-
like terms.
Oh.
We're,
You can
we're,
subtract 14 from a problem. You can't subtract 14 from a problem. It's 7 times 2. That's what
That's
you were saying.
kind of true, yeah. But no, we can subtract because they're like terms. That's the simpler way of putting it. Okay, I want to get this thing right here by itself, nothing else with it. So I'm going to add 18 to both sides. Negative 3 plus 18 is 15, and 15 is equal to 5x. This canceled out, and then divide by 5. Every step we take is getting closer and closer to having x by itself.
We went through an incredible journey within the last hour and 30 minutes.
You really have. Haven't you learned a lot of stuff about algebra in the last hour?
And now we can do simple algebra. We may
feel like
not
my
be able
brain- I
to
feel
do
like
the
my brain
crazy
already
practical.
Capped out? That's fine. Because I think it was better this week than last week.
Yeah.
I think there was a lot of information last week that you'd already just like, okay, I'm capped out. I'm full.
Yeah.
So let's stop there.
Sir, yes, sir.
And I'm going to go through your problem sets right now, actually, after I get my food. And I am going to...
Oh, yeah, right.
Last
So
week we didn't really
I'll
post
be
it.
eating right now.
I'm so hungry. I haven't eaten since
Ouch.
I have breakfast at 6.
Ouch. Have you heard of the heptathlon? It's a track and field event. And then my mom wants to sign me up for it. It's
Oh, is
7 track and field events within 2 days.
Wait, what
Heptathlon.
what's that?
It's 200, 400, 800, long jump, high jump, shot put, javelin.
Wait, I wonder
Sounds
if I just
excessive.
cancel all of the running. 'Cause I suck at running.
We all suck at running except him.
Wait, so 200, 400, 800?
200, 400, and 800, then a javelin, shot put,
Did you do it like all at
long
once?
jump, and high jump. You split it between 2 days, but it's still terrible.
So wait, how many months?
It's 7.
So what's the point of it?
I don't even know. I don't know.
Is it
You
like,
3.5.
wait, so is it cut in half?
Cut the 800 in half.
No, so is it supposed to be like fastest time and
I
Well,
don't even
it's
know how
true.
they score it. No one says, as long as you put down a score, because no one else is going to want to do it. I see why.
but like see no what's the point then? Why not just do the individual events?
Yep. Also, you can do it because no one signs up for it.
Yeah.
Because
No
no one's
wonder.
crazy enough
No
to.
wonder. Would Mr. Upton let us do it?
Maybe, because it's, I'm doing a summer track and field thing.
Oh, you are? Wait, is it the Fresno Flyers?
Yeah.
Oh, I would have done it last year.
All right, everybody, let's go ahead and get cleaned up. It is that time.
The first time you go, ask which, if you do that though, the first time you go, ask which college you're going to and specifically state which event you're going to go to. Because my sister, we accidentally went with the short distance running team and now she got sad.
Yeah. Yeah, I don't even know.
Honestly,
Whew. Oh, yeah, let's go ahead and stop this recording.